Here you go.
Thank you very much, Morten. Thanks, everybody, for joining, and thanks for the great assist that you have provided with the previous presentation. I have a lot of interesting, hopefully interesting stuff to say, and there's a lot of content, so it will be a bit fast-paced, so that hopefully you will have some time to ask some questions. This is the agenda. So why is it important to do data sharing and research data management? Very quickly, what is the problem behind it, which is basically knowing where the data sets have been published and how we have worked over time to come up with solutions to solve that problem, what we have learned in the process, and what we are doing now to hopefully find a very good solution for you. So why is it important? Well, this is a chart from with the Scopus data that shows that if the overall growth of publications worldwide has grown by 5% on average over the past 19 years, the growth of articles with data sets is 4 times faster. So research data management, best practices, and data sharing is picking up speed. And even if we look at the national scale, this is the Czech Republic. You see, although it's still pretty small in absolute numbers, it's just 2% of the articles that have associated data sets, and by that I mean that data are not like attached to the article as supplementary material, but they're put in a data set that is duly annotated with metadata, that has a DOI, and is linked to the publication, which is basically the best practice to make the data sets fair, right? So it's growing almost 10 times faster over the past 5 years. And if we look at the impact, so I would argue for the researchers it's not important for their careers, but it may be. Because if we look, and this is a trend that we see, a pattern that we see over and over, this is the same analysis for Czech Republic done. The yellow bubble is all the publications in the past 5 years, and the purple bubble is that 2% of publications with datasets. If we look at both the journal where these articles with datasets are published and the citations that they collect, you see that there's a positive impact on both sides. So I'm not saying that you do more research data management and more data sharing and then your impact will go up, but there's clearly something behind that, and that's why the funders have been putting pressure on the researchers to make the data available. So it's important, right? And why is it difficult? Because tracking data sets is difficult. You know, you could come up with, you have a research data management need at your institution, and you just launch a data repository for your institution. That will address the issue to some extent. And this chart represents more or less in a qualitative fashion the distribution of data. So the vast majority of data that your researchers are creating and consuming is private. So you don't see them and you cannot see them. And there's nothing we can do about it, right? Other than encourage your researchers to share more. But if you look at the 2 bubbles in the box, those are the data sets that will end up being published in your data repository that you have set up at your institution versus the data sets that will end up in other repositories, subject repositories and the likes. And to give you some data to back up this statement, we took the University of Virginia as an example. They launched their own data repository called LibraData in March 2016, based on the Dataverse platform. And as of the end of September this year, so we're talking about 3.5 years, they have 149 datasets published in their repository. But then we took a look at all the other datasets that are associated to the University of Virginia, and guess what? There's almost 600 other datasets that we could find that belong, that can be attributed to the University of Virginia, but are not published in their repository. So 80% of the data ends up somewhere else. And 20% of datasets in their repository is not bad at all, because we've done this analysis for a few other repositories, and we usually see that there's less datasets in your institutional repository than it's elsewhere, which it doesn't mean that you shouldn't have your own data repository. It's absolutely fine, and it's even recommended to have your own data repository, but don't expect that to solve your research data management issues. And librarians are aware of that, of course. This gentleman here is Dr. Andrew White, the head of the library of Rensselaer Polytechnic Institute, one of our development partners, and he's acknowledging that different disciplines and communities of practice have different data management needs and habits. And he takes an interesting position. So he says, I'm not actually interested in having my own data repository. I just want to make sure that wherever those data sets by my researchers have been published, they are published in the right way. So they're fair, they're duly annotated, they're safe, and all of that. So that's the only thing that matters to him. knowing where the data sets have been published. So we took this challenge and we tried to see how can we help institutions track the data sets produced by their researchers. And we started working on this problem in 2017 when we launched the integration between the Mendeley Data Repository and Pure. So we have our own research data management platform called Mendeley Data Platform. That's 5 different modules. One of the modules is a data repository. So we started by building this integration between Mendeley Data and Pure. And to the point that you were making, how do you encourage researchers to add data sets to Pure? You don't. As long as you're able to fetch dataset metadata automatically from the repository into your Pure system, you don't have to bother your researchers. You may want still to check the data and validate and do a little bit of that, but that doesn't involve the researchers at all. So the first thing that we built was to do that integration, but we're only covering, by doing that, the green bubble in the previous chart, and so the next challenge was how can we broaden that? So we presented that in last year, the Philadelphia solution, let's call it this way, which is an extension to the existing integration. We did this experiment with a few institutions, and I can see Anne and Bernard from Aalto and Namur, respectively, that have worked with us, and Manchester was another partner that worked with us that was mentioned before. And this was not fully automated. What we did basically was trying to find all the other data sets in different repositories, create an import file for Pure that you would then import using the bulk import functionality. So it was semi-automated. The collection was automated, but then the importing was not. But that would give you a broader perspective on the data sets by your researchers. And what we are presenting this year in Prague is basically the combination of the two solutions. So it's a fully automated ingestion of dataset metadata from the external data repositories, as well as, of course, your institutional data repository. So, well, the Mendeley Data Repository, someone was saying, and I couldn't agree more, don't use Pure as a data repository. Technically, it's possible, but it's probably not a scalable solution. So there are platforms, like Mendeley Data is one of them, but there are other open source and commercial platforms that do that are designed to host data sets. And the way this solution was working was fairly simple. You go to the admin interface, you enable the Mendeley Data integration. You just have to tell Pure, what are the data sets that I want to import? So what are the data sets that are attributed to my institution? And the way you identify your institution is by using the Mendeley institution ID. So you just copy paste the ID there, and then you configure the job, and the job then it works like any other import in Pure, right? Then you have the ability to validate or reject some of the candidate data sets that are presented by the system. So this solution, of course, has some strengths, because if you go by institution ID, then you don't have to do it a data set at a time. That would require, for example, the involvement of the researcher, so you can do it in batch mode, which is more efficient. The Mendeley institution ID is added automatically to the data sets in a number of ways. So if you're an institutional subscriber, then it's automatically added. We look at the affiliation of the Mendeley profile of the contributors, and if the institution is mentioned, then we use that information, and we also look at the email domain. So if it's an institutional email domain, again, we can associate that data set to the right institution. And if author identifiers are available on the metadata that we import and on the profiles in Pure, then the import is completely automated, and you don't even have to validate the dataset metadata. They just come in. And this is also available for non-Mendeley Data subscribers. So we do have a free layer for the Mendeley Data repository, and you don't need to subscribe to any additional module to have that. But, of course, it only works with the Mendeley Data repository. That's why we improved it in 2018. And that's a quick explanation of how we did it in 2018. So we start from the publications in the Pure system, and then we query a Scholix hub. Scholix, for those who are not aware, is a standard driven by the Research Data Alliance community that defines ways of storing relationships between publications and datasets. So imagine a Scholix hub as a big database where you have a publication with a DOI, for example, or any identifier. you have a data set with its own persistent identifier and a relationship. So if the relationship is the publication is supplemented by the data set, it means that the data set is part of the same publication unit, let's say, so you can associate it to the publication and you can import it. So we basically went through all the publications in Pure using the APIs. We check for any publication if there are one or more data sets. And if we find data sets, then we retrieve the metadata either from the original repository if it has an API or from datasite if it's using datasite. We do a bit of deduplication because there can be multiple versions of a data set. Data sets can be grouped into collections. So there are a number of things that we do to improve the data. We match the data set contributors and the publication authors. We link the publication to the data set, and that's what ends up in the XML file that then you import in Pure. And this is the result. So this is an example coming from, I think it's, yeah, from the Dryad repository. I was looking at the portal and trying to recognize. It's from you, right? Yeah. I asked you if I could use you as an example. Yeah. So you see that the internal persons are matched. We add the organizational unit based on the current affiliation of the internal authors. We add the links to the data sets for additional discoverability. We add the repository as a publisher if it's missing. And we add the link to the related publication. So I think it looks pretty good, right? And yeah, what are the strengths of this solution? It extends the 2017 version, so you can have it on top of the Mendeley Data integration. And of course, we deduplicate the records, so we're not importing records into your Pure system that are already there. And we link those data sets to the publications in Pure, because we start from the publications in Pure, basically. But it's manual, right? So it's not really, it's a bit clunky, let's say. So we improved that in 2019. And what we have learned in the process is that it's an obvious learning, but it's worth calling out. Metadata quality is really essential. And when it comes to data sets, unfortunately, the metadata quality is not that great. And not just in datasite. I mean, it's even in the original repository. So this is the same data set from CCDC, which is the original record, Cambridge Crystallographic Data Center, and they are great at collecting data sets, don't get me wrong. I mean, probably the majority of the data sets that your researchers are publishing is in CCDC if you have a department of chemistry at your institution. But even there, the affiliation is missing. So how can you say that this data set belongs to your institution, right? That's a big problem. And that's the problem that we tackled in order to come up with the solution that I'm presenting now. And the key, again, is colleagues. And the key is colleagues for two reasons. One is for data set discovery. How do you know that there are data sets out there that could be of interest for your institution? If you have the information about the publication, you know that that data set belongs to the publication, and you know the publication is coming from your institution, then most likely the data set is also coming from your institution or is relevant for your institution. So discovery. And what you see there is an actual record from Scolix, right? So that is a publication from that journal with the DOI. This is the relationship, is supplemented by, and this is the CCDC data set. So that's what we query, basically. And the second reason why Scolix is key is for metadata enrichment, because if the publication on the left-hand side of that relationship is indexed in Scopus, we have an awful lot of metadata of disambiguated author profiles, affiliation profiles that we can leverage, right? So we can basically take the author IDs from the publication and put it into the data set. And if there's a missing affiliation, we can pull in affiliation names and affiliation IDs on the dataset record, right? And enrich the dataset record with this additional information, which is exactly what we are doing in our solution. I mentioned that Mendeley Data is a modular platform. One of the modules is a search engine called Data Search that is designed specifically to index datasets. So we index datasets from around 37 or 38 repositories. We have 10.7 million datasets that are deep indexed. So we don't just index the metadata, we also index the files if they're available. So we started from there. And what we do, you see on the top left corner, the list of data repositories that are actually currently indexed in data search. We add datasite because we're not covering the entire world of data repositories. There are many more. Datasite has a lot of is basically a DOI minting service for data repositories and other things. So we add a datasite on top of that. But mind you, some of the repositories that we index do not use DOIs as persistent identifiers for datasets. Like that one, ProteinDB, which is a very important proteomics data repository, does not use DOIs. So you wouldn't have it in datasite. So we take our index, we add datasite, we add the relationships between articles and datasets from both OpenAir, which is one of the Scolic subs, and Crossref. And then we add the Scopus metadata to the mix, right? And we mix everything together, we deduplicate, we do the enrichment and everything. Everything ends up in our data search index, and it's then exposed via the APIs for consumption by Pure. And you can see you have multiple criteria to search for data sets. You can search by institution name or ID. You can search by author name or ID. This is all capabilities that the API is providing. And you can filter by object type. And that's another issue, because datasite seems the obvious choice to bring datasets in, but datasite is actually used to mint DOIs for a lot of things, including student thesis, for example. And you don't want to import a student thesis as a dataset, right? So we also give the ability to filter for the content type. And yeah, that's how the integration looks like, and you will see it. So instead of integrating with Mendeley Data Repository, we're now integrated with Mendeley Data Search. You still have to specify an institution ID, but now we support Mendeley institution IDs, Scival IDs, and Scopus IDs. So all the affiliation IDs that we handle are supported by our API. You can select the list of data repositories that you want to search against in the UI, and then the process works as it does currently, right? So it's the usual import process, including the linking to publications and so on. And as we had, same as we have now, where we have a free version and a paid version, we still have two options. So if all the data that is basically available in the public domain that we collect, we still make it available for free. So we don't charge if you're just interested in datasite information, for example. But if you want to access the enriched dataset, which is actually what really makes the difference in terms of the amount of datasets that you can discover, that's the bit that we charge for. And given that Mendeley Data is a modular platform, you can only subscribe to the data search module, and you'll have access to the paid, to the enriched records. And yeah, these are the different criteria that you can use to search for the free and the paid version, and the different type of metadata that you get in both versions. And yeah, the strengths, it's a fully automated process. It covers all repositories indexed in data search, including datasite. More on the roadmap in a minute. We do the enrichment. We automatically link to publications in Pure, and we keep the two access layers available. In terms of weaknesses, he will tell us how we can improve it. And to that point, we're looking for candidate partners that are willing to test the paid version with us. So if you're interested in taking a look, what we will do, we will select 3 partners that will have 6 months free access to the paid version. And the only thing that we ask in return is a little bit of feedback. Is it working? Is it not? So if you're interested, please reach out to Rachel De Levante, my colleague in the back. She will also be at the poster session. So just leave your name and institution and email address. And then we will announce the three institutions at the end of the Pure conference. I think I can skip this one. Roadmap. So the integration, we have 2 things, right? We have data search and Pure. The Pure version that will make available the free API integration is 5.16.0, due in October 2019. Is Chiara around?
Yesterday it was released.
Okay. Oh, great. Thank you. Yeah. See, you're great, guys. The next one is due in 1 month, so again, and that will offer the full integration. In terms of data search, we have already more or less everything available in terms of a rich content when it comes to the 40 repositories that we index. The data site content, curated data site content, will be available towards either the end of this year or early next year. So I think we still do have plenty of time to test this integration with you. That's it. Sorry, it was fast, but I wanted to give you time for a couple
we
of
still
questions.
have time for maybe one question before the next session. Oh, there you go.
I don't want to steal the show. Actually, I have one question first, of course, thank you for finally integrating DataSite. Next question is, when I look at the paid version where you kind of curate the DataSite input, if I have understood it right, then you can only curate DataSite stuff where, or datasets where there also exists a publication. Am I right?
Most of the times, yes. In some cases, the institution is mentioned as part of the metadata of the datasets, of the original.
But if it's not in the dataset,
it's hard to find, right?
Then you can only find it when there's a publication. So if I pay, I only get. That's not your fault, but then I get then I only get like curated metadata from datasets which are connected to a publication.
Yes.
But I still have problems with my datasets which are not connected to a publication.
In principle, yes, I agree with you. We have a solution for that as well, which is called Data Monitor, which is the 5th module of the platform, but that's not the topic for today. But if you're interested, please do reach out.
Thank you. Unfortunately, we are out of time, so we have to cut this session short now. Thank you very much to Alberto.